Hello everyone, welcome back to online maths hub. Okay, so we have this problem on the screen to solve right here. So this is 3 raised to power x is equal to 27 raised to power x minus 9 raised to power x. So we want to find out the value of x that actually makes this equation to hold. Okay, so we're going to be solving it, and at any point you actually start getting value in the video, you can do well to give the video a thumb up and also subscribe to our channel so that whenever we release new content you will actually get to know about it. So having said that, we're going to proceed right away. Okay, so solution. So let me rewrite my equation. 3 raised to power x is equal to 27 raised to power x and then minus 9 raised to power x. Okay, so first let me leave this one as it is, and then I'm going to write this one in power of 3, and then I will also write this one in power of 3. And if I do that, what I'm going to be having is 3 raised to power x is equal to, so 27 can be written as 3 raised to power 3. Okay, then if I multiply by this x, I will have 3x. Okay, minus 9 can actually be written as 3 raised to power 2, and then 2 times the x will give you 2x right there. Okay, now we can see that we can actually write this as 3 raised to power 3, okay, is equal to, of course you remember one of the rules of indices, which basically say that if you have a raised to power xb, you can actually write this as a raised to power x bracket b. Okay, now I'm going to write this as 3 raised to power x, okay, and then I'll put the 3 out, and then of course I will write this one 3 raised to power x and then all raised to power 2 right there. Okay, so the next thing I want to do is I can set my 3 raised to power x to be equal to m, and if I do that, I'll just go ahead and substitute. So this one becomes m right here is equal to, this one now becomes m raised to power 3 minus this one becomes m raised to power 2. So this is what I have at this point, and then let me bring this one to this side. Of course, if I do that, I'm going to be having that this is equal to m raised to power 3, okay, minus m raised to power 2 minus m right here, and it is going to be equal to 0. And of course you can see right here that m is all common here. I can factorize. So if I factorize m here, I'll be left with m raised to power 2 minus, if I factorize m here, I'll be left with 1m minus, if I factorize m here, 1 will remain, and it is equal to 0. Okay, so using the zero product rule, which basically say that if you have a times b is equal to 0, this actually implies that a is equal to 0 or b is equal to 0. So you can clearly see that from here that my m is actually equal to 0. Okay, and or m raised to power 2 minus m minus 1 is equal to 0. So there are two cases right here which we are going to consider. And so if m is equal to 0, now you remember we set our m to be equal to, from here we set our m to be equal to 3 raised to power x. Okay, so if our m is equal to 0, we now have that and so if our m is equal to 0, we now have that 0 is equal to 3 raised to power x. Okay, so from here you can see that there is no single value of x for which if you raise 3 to it, it's actually going to give you equal to 0. So which means that m equal to 0 cannot actually be our answer. So you cannot satisfy this question right here. So what we need to do again, we can resort to this second one right here and then see if we can get a solution for the problem. Okay, so resorting to this second one, we have that m squared minus m minus 1 is equal to 0. So what we are going to do is, because this is a quadratic equation, we are going to be using the formula method to solve it. Okay, so of course in our formula method, our m is now going to be equal to minus b plus or minus the square root of b squared minus 4ac, okay, all divided by 2a. Okay, so from here, from this question right here, you can see that our a is equal to 1, which is actually the coefficient of m squared, and then our b is equal to minus 1, which is the coefficient of m right here, and then our c is also equal to minus 1, which is our constant. So we're going to replace it right here, and then we'll begin to also evaluate from there. Okay, so what we have here is that our m is equal to, and so b is actually minus 1, so we have minus into minus 1, okay, and plus or minus the square root of minus b, okay, so b is actually minus 1 squared, that is b squared, okay, minus 4 times 1 is a is actually 1 times c is minus 1, okay, and it is all going to be divided by 2a. Okay, so at this point we can continue to simplify, and then we're going to be having that this is equal to 1, okay, plus or minus the square root of this one will give us 1 minus, okay, minus times minus here is actually going to give us plus, okay, 4 times 1 times 1 will also give us 4, and it's all divided by 2a. Okay, our a here is actually 1, that is 2 times 1, okay, so 2 times 1 is also 2 from here. Okay, now proceeding, we have that this is equal to 1 plus or minus the square root of 5 all divided by 2. So you can see from here that we have two variables, we have two expressions for our m. So the first one is that m is equal to 1 plus root 5, okay, all divided by 2, or 1 minus root 5 all divided by 2. Okay, so moving on, at this point we recall that we actually set our m to be equal to 3 raised to power x. Okay, now these are the values of m that we have right here, but first, if you consider this one, you're actually going to be seeing that this is going to be giving you a negative answer, and if you put a negative answer here, there is no value of x where you take 3 to the power of it and it is actually going to give you a negative answer, so which means that this one is not actually going to work. So this one cannot be a solution because it's actually going to give you a negative value. So this is the one we'll go ahead to consider. Okay, so our m is 1 plus root 5 all divided by 2 is equal to 3 raised to power x. Okay, now so what we are going to be doing right here is we want to take the log of both sides. So we want to take the natural log, so we say ln 1 plus root 5, okay, and of course this is put a big bracket all divided by 2 is equal to ln, okay, 3 raised to power x. Okay, now using the property of ln, this is actually going to come down, and then I'm going to split this one right here because one of the property of ln would basically say that if you have a ln, let's say a divided by b, you can actually write this as ln a minus ln b. Okay, so I'm going to use that right there, right here, and of course I'm going to be having that this is equal to ln, okay, 1 plus root 5 minus ln 2 is equal to, and then this one I'm going to bring it down here, that is the property of log, so I'm going to be having x ln 3 right here, and so to get my x I'm going to divide through by ln 3 right here, and I'm going to have ln 1 plus root 5, okay, minus ln 2 all divided by ln 3, okay, is equal to x. And of course this is actually going to be our final value. If you actually use a calculator and evaluate all of these things, this is actually going to give you a number. This will give you a number, so if you evaluate all of it and then get your solution, that is going to be the value for x. And then if you come over to our question right here and put it you're actually going to see that it will satisfy this equation right here. Okay, so thank you so much, guys. That is where I'm going to be wrapping it up. Make sure you give this video a thumb up, subscribe to our channel for more updates, and of course I'm going to see you guys in my next video. Bye.